Hi, third grade. Today we are going to be going over lesson 108 for our math instructional video, which is on formulas and distributive property. Our objectives today are to use formulas to find perimeter and to use the distributive property to solve multiplication problems. Now, we have been doing power-ups on area and perimeter since we came back to school from Christmas break in January while we were getting ready for state testing. So I think that you will do pretty well with that part. And I know that a lot of you have seen problems about distributive property in your accelerated math problems that you get. I am going to be 100% honest. This is one of the lessons that I get nervous about teaching every year because from just the way that God made my brain, distributive property is hard for me. It's just not the way that I can visualize a problem the easiest. For me, I just want to keep doing that straight PEMDAS, parentheses, exponents, multiplication and division, addition and subtraction. But for some people, especially if you don't have all of your facts for multiplication memorized, distributive property might be a way to chunk it down so that you can look at it as problems that you already know. So I am going to try my best. I'm hoping you are willing to try your best, and hopefully we can get through this together and have it make some sense. I am very confident, based on how all of our virtual learning has gone so far, that you guys are going to understand this better than I do, because lots of the things that we've been going over, and especially the technology related things, I have been really pleasantly surprised at how quickly you guys have been able to catch on to things that have been really hard for me to learn and really hard for me to figure out, especially Google Classroom. You guys are pros at that. So I was looking for my marker and it was underneath our worksheet for today. So this is the worksheet in your Learn at Home packet. It says Reteaching 108 Formulas and Distributive Property. Now, the formula part is just using a different term for stuff we've already done. So we're going to go over this, but most of the examples I'm going to go over are going to be using distributive property, because if your brain happens to be like mine, then that's something that you need a little extra help on. If you don't, that's totally fine too. We are all different. So at the top of your worksheet says a formula is a rule for finding the answer to a problem. And so they give you an example of area equals length times width. And we know that, we've gone over that in Power Ups. You guys are really, really good at knowing the difference between area and perimeter. And so knowing that you need to multiply to find the area, knowing that you need to add to find perimeter, those rules can be put into a formula that's just using a different word. And this can also, you can kind of think of this a little bit like lesson 106 from 2 lessons ago with evaluating expressions, because you will see in this common formulas chart on the side that they use some letters to fill in for the formula. This is similar to the variables that we saw in that evaluating expressions lesson. So all of those letters are technically variables because the value of that expression will change based on what number needs to go in for each of those variables. So they give you examples, like formulas are usually written with letters for abbreviations. So the capital A means that's what you're trying to find. So the capital A means you're trying to find area. And then the formula is LW. Remember when 2 letters are written right next to each other, or it's a letter and a number written right next to each other? That means that we are supposed to multiply that variable times that number, or those 2 variables by each other, or 2 numbers by each other. So to find the area of a rectangle, they have area equals length times width. And those are variables because depending on what the length of that rectangle is, what the width of that rectangle is, you're going to have a different answer for your capital A for your area. So if I had a rectangle that was 2 inches by 4 inches, if my width was 2 inches and my length was 4 inches, I would have an area of 8 square inches. But if my length was 5 inches and my width was 1 inch, I'd have 5 square inches. So they're variables because they can change, but they still will always stand for the length and the width. They also say this chart shows common formulas. P represents perimeter, so they have some perimeter of a rectangle, and they have P equals 2L, 2 times your length, plus 2 times your width. Instead of doing length plus width plus length plus width, they are multiplying 2 times the length plus 2 times the width. And then up here where they have 2 times L plus W, that's distributive property. And we're going to go over that a little bit more in the bottom part of this worksheet. S represents the length of a side of a square. So when they have on here area of a square, they have A equals S squared. Remember that exponent 2 means squared. That means how many times are you multiplying the base by itself. So one side of a square times the other side of a square, because squares have equal sides, will equal my area. So if my square has 2 inches on each side, it'll be 2 times 2, 4 square inches. B represents the base of a triangle or a parallelogram. So they have the area of a triangle over here. This is nothing we're going to do in 3rd grade math. This is something I remember from geometry class, but you would multiply the base of the triangle. That's the bottom part, if you remember from the geometric solids or the parallelogram assignments, times the height, which is how tall it is from the top, the top vertex to the bottom, and then you're going to divide it by 2. To find the area of the triangle. And then H represents the height of a triangle or a parallelogram. Now to use those formulas illustrating distributive property, and this is the part we are going to concentrate on the most, and this is the part that you're going to be doing on the bottom of the worksheet. The bottom part of the worksheet is going to deal with the bottom part of the explanation. So the formula for the perimeter of a rectangle demonstrates the distributive property of multiplication. So the perimeter can be 2 times the length plus the width, because remember, opposite sides are equal in a rectangle. Or you could say the perimeter is 2 times the length plus 2 times the width. Now this is where I get very, very confused, especially when it's just variables. So they have all of these arrows and these letters, and they're saying, so I'm going to do 2 times that times L, and then I'm going to do 2 times W. That's the same thing as saying 2 times L plus 2 times W. That is confusing for me. Maybe for you, that makes perfect sense. A lot of you have been doing this in accelerated math already, and there haven't been a whole ton of questions about distributive property in accelerated math. Like, you guys are doing pretty well on this. You're not coming and asking me a lot of questions during that part of our day. So I'm guessing that maybe you understand this better than I do. With numbers, it makes a lot more sense than when I'm just looking at this formula and those are variables. Kind of like that evaluating expressions worksheet. Looks very, very complicated because all you're looking at is a whole bunch of letters. That's why I said in the notes on your assignment, rewrite those problems with the numbers. It'll make more sense. That's what happens in the example at the bottom. That's what I'm going to be doing on my whiteboard for you now. So let's say that the problem that I have is 3 times 12. Now, maybe you know all of your 3 fact timing, maybe you know your 12 fact timing, and maybe you can figure out in your head that 3 times 12, maybe you have it memorized, is 36. Maybe the 12s are really difficult for you and you want to chunk that into pieces that make more sense, just the way that your brain works. So you could do 3, and remember, parentheses right next to something means I'm multiplying, 3 times. And if I look at 12 and I want to chunk it into numbers, a lot of times 5s and 10s are easier for us. 2s are usually pretty easy because you're just doubling a number. I'm going to change this to 10 plus 2 because 10 plus 2 equals 12. So this is the exact same problem, as this problem. It's just written a different way. 3 times 12, this is technically 3 times 12. Now remember our order of operations, PEMDAS, tells us what order to do things in, and we start with, first we do parentheses, then we do any exponents, then we do multiplication and division, then we do adding and subtracting. So if we were going to do PEMDAS, I would look at this problem and I would say, oh, I have to do the parentheses first. That's 12. It's 3 times 12. So you can see that it's the same problem as just the 3 times 12 at the top. It's just written a different way. So maybe that makes sense to you that way. But if you want to do distributive property, I can look at this and say, instead of doing 3 times 12, which is the value of the expression in parentheses, I could say 3 times 10, because this means I'm multiplying it by anything in the parentheses. That's where those arrows and those letters came in on the worksheet. I could say I'm doing 3 times 10, and then I'm going to add it to 3 times 2. And maybe 3 times 10 and 3 times 2 is easier for you than doing 3 times 12, because I know that I just have to add a 0 if I'm multiplying by 10. So 3 times 10 is going to be 30. And 3 times 2, 2's are usually pretty easy for us because that just means I'm doubling. So I'm going to do 3 times 2 equals 6. And now I have 30 plus 6 equals 36. These are the exact same problems. They're just written a different way and done in a different order. And depending on how God made your brain, maybe 3 times 12 is easier for you. Maybe you like doing PEMDAS in the straight order. Maybe you want to chunk it into ones that are easier and you're like, instead of adding 10 plus 2 first, I'm going to do the multiplying first. I'm going to do 3 times 10 and 3 times 2. Then I'm going to add. I'm going to give you another example, and I'm going to use my favorite multiplication problem. I have no idea why this is my favorite. Just like when I was in 3rd grade, I don't know why Mrs. Ford's favorite problem was 7 times 8 equals 56. She didn't know either. I have no idea. But 4 times 7, for some reason, is my favorite multiplication problem. I don't know why. There's no reason. 4 doesn't have a special meaning to me. 7 doesn't. Neither does the number 28. But I love 4 times 7 equals 28 for some reason. So if you have your 4s or your 7s done, maybe you have that memorized. You can say, oh, 4 times 7, that's 28. Easy peasy. Maybe, because 7s are usually facts that people struggle with a little bit. So maybe it's going to be easier for you to chunk this into pieces. So instead, I could say it's going to be 4 times. Remember, we said 5, 10s, and 2s are usually the easiest facts. So I could say 5 plus 2, because 5 plus 2 equals 7. So this is still asking me 4 times 7, because if I did PEMDAS, parentheses, 7 times 4, still going to equal 28. This is the same exact problem. It's just written differently. So now, instead of doing my parentheses first, I am going to do my multiplying first. So I'm going to say 4 is being multiplied by 5, and 4 is also being multiplied by 2. So I'm going to do 4 times 5 plus 4 times 2. Then I know 4 times 5 is 20. 4 times 2 is 8. 20 plus 8 equals 28. So on your worksheet at the bottom, there are 4 problems, and they're using distributive property in 2 different directions. So first they give you 5 times 2 plus 10. You could do PEMDAS, and you could say, oh, I know what 10 plus 2 is. I'm going to multiply that sum by 5. But that's not how they want you to do this problem. So you will need to write down 5 times 2, and then you're going to add that to 5 times 10, and then the answer. They want you to write out distributive property. Same thing for number 2, 8 times 2 plus 7. Maybe you know what 8 times the sum of 2 plus 7 is, but they want you to use distributive property just so that you learn a new method of doing the same type of problem that we've already worked on. So you need to write it out as distributive property. At the bottom, then, they have 2 more examples where they've broken down a multiple into easier pieces to multiply by. If you want to do PEMDAS for 3 and 4, that's okay if PEMDAS is easiest for you. If you're like, hey, I love this distributive property, that makes a lot of sense for me, you can use distributive property for those 2 at the bottom. You can use your choice as long as you come to the same answer. It doesn't matter what kind of a method you use, as long as the method gets you to the answer. So use for 3 and 4, use whatever you are most comfortable with. And I think that there will be a pretty good mix in our class, because that's the cool thing about how God made everybody differently. Some people's brains like PEMDAS, some people's brains like distributive property. And so some of you will prefer one and some of you will prefer the other, and that is okay. I'm looking forward to seeing who chooses with which method on your worksheets. Have a great day, third grade.